Uh, Hi. Uh, Now I will tell which are the things you need to edit in the exam. Okay, you need to edit this thing. So this you need not rename it. Just you go to that file and edit this data with what they give for the exam, right? So for the trial exam they gave like this. So while editing, please don't enter these values, gender size. Please don't enter the attribute values. Just enter these values. What are the things which are below the attribute? F. Don't enter the first row. Okay, like this. Just enter these values alone. And while entering, be careful. Okay. After entering these values, read the question. If he has given you the some node and he is asking what will be this node and what will be this node based upon the conditions, right? If he is asking question like this, then we need to proceed with in which way I am saying now. But if he is not asking like this, and if he is asking questions which is the root node and which is the next to two children of the root node, like that, if he asks, right, then I will tell how to do it. So first, for this type of question, he is giving a root node for himself and he is asking the two nodes for what will be the other two nodes based upon this condition. He is putting the root node into size and m into one thing and l and xl into other thing. So for this type of questions, what we need to do is that, okay, so we enter this number of columns is nothing but the number of row columns 1 2 3 4. Okay, and always remember that the target letter, the T, should be capital letter. These are things we can do it whatever we want. Whatever things you are using here, you should use here and elsewhere in the program. Okay, and if there are some numerical values, right, some like temperature and humidity, those things, right, you just typecast them as float over here, which I have given you in another example. You can see the example for those things. So while doing it, if it is numerical value, just get the input as the float value. Okay, then you need to identify the categorical attributes of the given question. So gender is categorical, size is categorical, color is categorical. Okay, and class attribute you don't need to worry. So all the three are categorical attributes and numerical attributes is nothing, so leave it as an empty set. Okay, this attribute criteria, you can just, for reference you can just like that write, or it's not needed for, but for reference you can just write for you. See, for gender it's male and female, for size it is S, L, XL and M, color it is red, blue, green, and class color is red, blue and green. Okay, so write all these three things. See, remember in these things you no need to worry about this class attribute. Okay, I write these things and so these are the 4 lines to edit: number of columns, the given data, and this attribute names over here, and the attribute criteria, and this category attribute. These 4 things you need to edit, and after that you can go. See, while running, I'll run slowly. Kindly check that you are getting the data over here. If you're not getting any data here, then it's waste. Then it's waste to run here after. So then you have made some mistake over here itself. So kindly check if you get the data over here. If you get the data, then it's no problem. Then you can proceed. This is just calculating the class entropy. If it's not needed, for just reference, I have just calculated it. Okay, now remember these things. I have written 2 functions, process and process root. So if you want to find the root node from the given data, right, so you can use this function. if you want to, if he has given the root node directly and he is asking the remaining nodes, right, so you can use this function, you can use the process function. So now for the given question, he has given the root node himself and he is asking what are the remaining two nodes, right? So just call the process function over here. Before that, you need to just enter, you need to edit the two values alone. In that split index thing, you need to edit under for which thing, which attribute is splitting. He is taking as the splitting criteria. So he is taking the size as the attribute to split, right? For the size, he is splitting based upon two things: S and M together as one side and L and XL together as one side. So first we will find the node for S and M. Remember, he is joining both S and M together, right? So he is joining both S and M together. So you just write the size over here and S and M together and then run. If you run, you will get the attribute with maximum color, you will get it, and you can find the attribute with maximum gain as color, and you can get the information gain of your color over here. And again he is asking the node for L. And one more thing I forgot to tell, right? This two things, this thing you have edited, and for this attribute criteria, right? So we have written the attribute criteria over here above. So if you want, so this attribute criteria is necessary, I think is necessary. So now he is splitting based upon the size, right? So remove the size alone. So remove this line from the attribute criteria. Remember this thing, where is this thing? Okay, yeah, whichever thing you are splitting, you should remove. This is the main step. This two step you need to perform it correctly, or else you will not get the correct output. Whichever thing you are doing it here, right, the category attribute you are splitting, this thing should not be here. Okay, so remove that thing over here. Rest of the thing should not be changed. So we remove the size value alone from this thing, like this. See here, this size is there, so remove this size value alone from this thing. Okay, now we calculate for S and M together. Next we need to calculate for L and XL together. So for L and XL I am doing it over here. Again for this L and XL, size is, again for size we are calculating, right? So for size we have calculated for S and M. For size we are calculating for L and XL. So size is here, so this value should not be here. So the same thing, just change the L and XL and calculate. You will get the maximum attribute gain with as the color, and its information gain is 0.166. So this is the answer, and this is the 2015 question paper. So he has asked the Gini impurities and those things. These things I have given a separate notebook for you. You can either use that one over here, Gini computations. So I have given separate examples for all these things. Entropy, overall entropy, categorical entropy specific. If he asks the entropy of the color red, right, you can calculate over here. And if he is asking the entropy for numerical attributes, some less than or greater than, you can calculate it over here. Okay, if it is two things, right, s less than or equal to, for less than the entropy is 0.811, for greater than it is 0.1, entropy is 1, like that you need to find. Similar things for the Gini also. If there are two values, right, you will get two things for numerical for 75. So for less than 75, it Gini impurity is 0.42, for greater than 75 it is 0.5, and similar thing for classifierers. So this is this thing, and for the overcast, the exercise example, right? So this is this thing. Again, see what I'm editing. We need to edit this data, and the number of columns for the this thing is 1 2 3 4 5. So we'll be entering the 5 values. The number of columns we need to change, and these things we need to change. See, for outlook, temperature, humidity, windy, and target, remember that T should be capital letter, and for numerical attributes, convert them into float as typecast over it here. Okay, and write down the categorical attributes and numerical attributes from these things, and write the attribute criteria, fill the attribute criteria like this. For outlook, there are sunny and overcast. Don't change the syntax, just edit the values. Okay, so here sunny, overcast, and rain are separate, right? For the previous question, he combined small and m together, right? So if we asking to combine together, if we ask sunny and overcast to combine together, you need to do it like here: sunny, comma, double quotes, overcast, like this. Okay, you can either refer this example, or you can get the syntax from that this thing. I have done it over here, right? So you can get the example over here. Say I have grouped it over here. Okay, then we can run. And here he has not given any root node, right? So we need to calculate the root node. So to calculate the root node, we don't need to have any split criteria. I have told that I have written two functions, right? Process root and process. So you need to call the process function here, process root function here. So because we need to find the root node. Okay, and the attribute criteria is just like that. Whatever we copy the attribute criteria, whatever we wrote it over here, over here. Okay, and just if you run it, you will get the attribute with maximum gain is that outlook. Okay, so information gain of outlook is 0.24. This will be our root node. Now we got our root node, so hereafter we will be getting the subnode. So hereafter we will not be using the process root function, so we will be using the process function. For process function, we need to give the split index condition. So the split index for outlook, it has three things, right? Sunny, overcast, and rain. So whenever you find the root node over here, you can just check attribute over maximum gain. Here for outlook is the attribute maximum gain, right? So you can go for outlook, you can just check the entropy values of all these things. If the entropy value of one thing is 0, then it is the leaf node. So for overcast, the entropy is 0, so and hence you can write the overcast value as for all the four things are yes. So if it is overcast, then it is yes, so it is a leaf node. Now we need to compute the nodes for the sunny and rain. Rest of the things I have given in the first video, so it's a very brief process. Okay, you can just keep on constructing the tree. This thing I have explained it in the first video, you can see it over there. That's all.